Okay, this is the P3 paper from January 2023. It's a functions and graphs question, in particular a modulus function question. Part A focuses on, in effect, being able to sketch that out so we can work out the points P, Q, R and S. And then part B is just solving this modulus equation here. So we'll look at part A first of all. And just in advance to let you know, what I'm going to do is I'm going to do this quite slowly using more steps than I might do if I was racing through the exam to do it, but just to make sure that my students sometimes find this particular topic quite difficult. So breaking it down massively so that we're able to do part A for certain. So for part A, there's 4 marks, 1, 2, 3, 4. So, you know, allocate the amount of time that you need depending on how quickly you can do everything else in the paper. But I'm going to do it slower than I would if I was doing the exam. So let's make a start and get going with it. So what I'm going to do, in effect, is to just draw this thing out from scratch. And as I draw it out, I'll work out that one and that one. I think they'll come out first of all. And then these two I'll need to get from a bit of algebra. But let's go ahead and make a start to that. So if I'm trying to draw the graph, what I would start off with is actually just drawing the graph of, let's get this axis drawn in, y, x. Eventually I want to get to y equals modulus 3x minus 5a minus 2a. I'm going to start off just with what 3x would look like. So y equals 3x is going to look like that. And if y equals 3x looks like that, then y equals 3x minus 5a is simply going to be a case of translating this graph down 5a units. So this is probably the first bit that I would record then, that if I've done that, this is now the point at minus 5a, and if I want to work out that point there, this is just going to be where y equals 0, so 3x minus 5a will equal 0, so x will just be equal to 5a over 3, 5a over 3, and I'll leave that as my first graph then. If I'm going to do the modulus of that then, and say you could do this all on one graph, I'm just sort of doing it step by step here. Going from that graph to the next graph then, all that's going to happen now is, excuse me, is that when I do the modulus graph, we're going to get a reflection, aren't we, about the x-axis there. So this is still going to be the point 5a over 3, but this now becomes the point 5a. And this is the graph of y equals the modulus of 3x minus 5a. So if I'm now going to do that one and take minus 2a off it, when I take minus 2a off it, the whole graph is just going to move down by 2a units. So if that happens then, do a final sketch. As I say, in the exam, probably a little bit of overkill on this, but at least I'm happy I haven't made any mistakes as I'm going through and doing this. So if it moves down to A, then when I draw this new one in, I now know that this point here is 3a because the 5a moved down to. I know that this point here, so that's that point. I know that the minimum point now is still 5a over 3, but it's 5a over 3 and minus 2a. We dropped it down to a there. So what that means is that I've got P and I've got S already worked out. What I don't have is Q and R yet. So let's go about doing Q and R. In fact, no, let's leave all those on there then. So now, in order to work out Q and R, so for Q and R, I am going to go algebraically now, and what I'm going to say is the function that I've got, which is modulus 3x minus 5a minus 2a equals 0, is then going to give me 3x minus 5a equals 2a. And at this stage, remember, what we can then break it down to, if I've got the modulus, is, and I'm going to get two values. I can see I've got a value for Q and a value for R. So that's going to be 3x minus 5a equals 2a, and then the negative of that, so minus of 3x minus 5a is equal to 2a. And if I just solve those two, then this one's going to give me 3x equals 7a, which will give me x equals 7a over 3. And then the other one for a negative gradient is going to give me, what's that, minus 3x plus 5a is equal to 2a, which is going to give me minus 3x equals minus 3a, which is going to give me x equals a there. And then what you could do is actually check those and see that they make sense in terms of the x equals a one. A is less than 5a over 3, and for r it's going to be greater than 5a over 3, so those two both work for that. And also, obviously, when I was doing the positive 3x minus 5a equals 2a, I've got my positive gradient there, so of course that makes sense that that one works out to be the 7a over 3, and that one works out to be the a. Now that's all sort of extra stuff, you don't necessarily need to understand all that, but it makes it easier if they try and do something more complicated, which they will do with the second part. Let's make sure we've answered all our actual questions then. So part 1 said, what's p? That was from the graph, that was 0, 3a. Then part 2, which said, what's q and r? Q is equal to a 0 now, and r is equal to 7a over 3 0. And then part 3, which we've done again from the graph, s was equal to 5a over 3 minus 2a. So always make sure you've actually gone back and answered whatever it is that we're looking for. And then on to this second part, oh, no, that's not the second part, to this second part here about drawing this graph out. Again, you might want to just fast forward through the graph part that I'm doing, but I think the graph part's important to work out when we're doing our algebra. What am I doing? Am I doing the minus of that is equal to the positive of that? Am I doing that the positive of that is equal to the positive of that? Am I going to do any variation of those? So a quick thought process about this. Again, if I was doing it in the exam, I don't know how much time I would spend on this graph, but obviously I've got the luxury here of, this is an explanation video, so I can take a little bit more time over it. So what we're doing then is, if we're trying to equate these two things, we could draw the graph out relatively accurate of what we've got here. Now, we had our original graph that we had drawn in here. We knew these points. We've just done quite a bit of work on that one. Oops, sorry. So I know that this is the point 3a. I know that this is the point a. I know that this is the point 7a over 3. It doesn't really matter what that point is here. It's comparing this one now then, whoops, to the modulus of x minus 2a, which I'm going to do really quickly. So y equals x would look something like that. Okay, y equals x. And importantly, just be aware of the fact that this gradient is not as steep as this gradient, because I'm comparing x to 3x, aren't I, with the two gradients. So that's what y equals x looks like. So if that's what y equals x looks like, then the modulus, goodness sake, the modulus would just look like that. And then if we're doing modulus of x minus 2a, that's going to be a shift to the right of 2a units. And what that's going to do then is it's going to put it here, slap bang in the middle of a and 7a over 3, and also it's going to hit here at 2a because it's a gradient of y equals x. So the accuracy of this graph then, in fact leave those on, the accuracy of this graph then means that when I'm trying to now work out where they're equal to each other, I'm going to get this point here, and I'm going to get this point here. Now, if we look at the right-hand one first, I'm just going to call these A and B. I would not do, I repeat, I would not do all this work in the exam. This is just trying to explained it to you guys to sort of support you with what you're doing. If I'm looking at point A there, okay, this is the positive gradient of my original graph, the positive gradient of my second graph. So what I'm going to be doing there, where I've got, let's write it out. This is what I'm trying to solve. 3x minus 5a minus 2x is equal to x minus 2a. For point A here, I'll just show off as I've actually done all that work there. Point A is going to be where the positive one here and the positive one there are involved. So I can just say 3x minus 5a minus 2x is equal to x minus 2a. This is positive. This is positive. Don't need to put any brackets in. If I look at point B then, it's pretty much the opposite. It's where I've got the negative of this one and the negative of that one in terms of the two graphs, in terms of the two gradients. So what I'll do when I'm doing that one then is to have minus of 3x minus 5a. The minus, sorry, apologies, that should be 2a there. Should be 2a there. And the reason I've noticed that is because, the minus 2a, that's not affected by anything. Okay, that's just a shift over. And that's going to be equal to the minus of x minus 2a there as well. So now I've got everything. Now I can go through and actually do that, and I'll get all the right answers. But I know that my algebra will now work as I'm going through and doing it. So 3x minus 7a is equal to x minus 2a, that gives me 2x is equal to 5a. That gives me x is equal to 5a over 2. And then if we do, which again, on here, further on than 7a over 3, greater than 7a over 3, which just makes sense with what I would have thought here. And then for point B, I'm going to get minus 3x plus 5a minus 2a equals minus x plus 2a. Just be careful tidying all that up. What am I going to get? In fact, take the x's over to the other side. On this side, I'm going to get 2x. On that side, I'm going to get 3a. I'm going to get a, I'm going to get a equals 2x. That's not the answer. So x equals a over 2, which again fits in with where I would expect the x value to be there. So happy days. X equals 5a over 2 and x equals a over 2 are the two solutions to the equation for part B. Hopefully all that makes sense.